Okay, so this is the first video, section 12.1. I want to talk about events, like a simple event, and the two I'm going to look at is toss a coin or roll one die. And our sample space are all the outcomes that can happen. So if you think of tossing a coin, the only thing that can happen is it can come up a head or a tail. If you roll up one die, well, it can come up a 1, 2, 3, 4, 5, or 6. So we call these the sample spaces of these simple events, meaning there's only one thing going on. Now, we're doing all this because we're leading in the probability. That's why we learn to count. So I know you know some stuff. If I ask you the probability of getting a head when you toss one coin, you're going to tell me, well, it's 50-50, or the probability is 1/2. There's one way to get a head out of the two total outcomes. Here, if I ask you the probability of roll a 6, there's 6 total outcomes. That's why we find the sample space, and there's one way to get a 6. How about if I ask you the probability of an even number? Again, there's 6 total outcomes, and there's 1, 2, 3 ways to get an even, so that probability is 1/2. I'm going to show you a couple ways to do sample spaces with what's called multi-stage, or you may hear the word compound event. So I'm going to roll 2 dice. And I'm going to make a table. I'm taking a deep breath because this isn't fun. But, okay, so if I look at the first die, it can be a 1, 2, 3, 4, 5, or 6. Then over here in my table, I'm going to have the second die. Well, notice how I'm pairing it up with the second die all being 1. So if the first die is, say, a 3, the second die is a 1. The next thing in my table is the first die can always be a 1, 2, 3, 4, 5, or a 6. But now let's look at the second die being a 2. And again, the first die, 1, 2, 3, 4, 5, or 6. Second die can be a 3. And you see the pattern that's going to go on here? My table's getting lopsided. Two more columns. So this is one way to get the sample space for rolling 2 dice. Now, If I look at this, you can see there's 36 outcomes, which in the next video we'll talk about the accounting principle. But now I can ask you a problem such as this. What's the probability of rolling 2 dice and they add up to be 7? Well, we did our counting. I know there's 36 total outcomes, and where are all the 7s? They're on this diagonal, and we can count there's 6 of them. So that's why we're learning to count. Okay, now I'm going to do a tree diagram. I'm going to toss 3 coins. So we know that the first coin can be a head or a tail. Then I look at the outcomes for the second coin. Well, if the first one is a head, the second one could still be a head or a tail. Here, first coin, tail, second coin, head or tail. So now I'm going to add the third coin off of here, also head or tail. Off of here, a head or a tail. Off of here, head or tail, and finally here. So take a second. How many total outcomes are there? You might want to pause your video for a second just to answer this question and count them. Now I assume you're back. There's 8 total outcomes. For example, I'll circle a couple of them. There's one, a head, tail, tail. Here's another one. Tail, head, head. And now I'm going to ask you, what's the probability of 2 heads and 1 tail? Again, we know there's 8 outcomes. How many of the events have 2 heads and 1 tail? Let's circle those in red because I can't erase. Here's 2 heads and a tail. Here's 2 heads and a tail. And here's 2 heads and a tail. So that gives me 3. So the probability we get 2 heads and 1 tail is 3 out of 8. Very quickly, what's the probability of 3 tails? Again, there's 8 total outcomes. Only one way to do that. So this is the first video for this section. I'll see you on the next one.